Okay, hello everyone, it's Melissa, your math teacher, and just wanted to do today a little bit on transformations of functions. Wanted to show you how I use key points to transform functions, and you can choose to do it the way that the online program teaches you, or you can choose to do it this way, so whatever works for you. So the first thing is, in section 2.6 in your book or online, either one, you're going to notice, actually sorry, it's in 2.5, you're going to notice that they give you a library of functions. Okay, so I mean this is just in the book, I'm sure you can see it on the online program as well. Notice that they give you identifying, you have the squaring function right here, you have lines, you have constant function, which is just a horizontal line, you have the cubic function, you have the absolute value function, the square root function, and then flip the page and you have the reciprocal function and the cube root function. Greatest integer function, we're not going to use that much. Okay, all of these functions, you basically need to know the gist of all of these functions. This is on page 257 in the book, so you could pull that up online. Because you may be asked to transform any of them. Okay, so just as an example, I'm going to talk about the basic function of y equals x squared. Okay, and if you know anything about that, it's a parabola. The basic function is just, it's going to be u-shaped like this. Okay, but let's put some specifics on this. Let's get some specific points. So if I do an xy chart, okay, I can choose some values for x and find what the corresponding values of y are if I plug them in. So for instance, if I plug in, if I say let x equal 0, when I plug 0 in here, I'm going to have y equals 0 squared. So that's just y equals 0. So when x is 0, y is 0 for this square function right here for the parabola. Okay, let's choose some other values. I think I'm going to choose -1 and 1 and -2 and +2. So as I plug these in, y equals -1 squared, that's going to be a +1. And y equals +1 squared, we get a +1. And you can see if I plug -2 in and square it, I'm going to get a +4, and the same thing happens with a +2. Plug it in and I get 4. Okay. These are what I call the key points. So these are the basic points that we would use anytime we're trying to shift a quadratic around a graph. Okay, so for y equals x squared, the key points are going to be 0, 0, -1, 1, 1, 1, -2, 4, and 2, 4. Okay. Now, when we're asked to transform y equals x squared, so if there's something added or subtracted on the inside or the outside of the function, or if it's multiplied by a negative, then we're going to have to fiddle with these key points here. And I think it's easiest to work algebraically with the key points off of the graph, and then adjust those points, and then just graph your function. Okay, so let's take an example. So there's our key points. Let's say that we want to graph something like f of x equals maybe x minus 2 squared plus 4. Okay, so effectively what this is doing right here, this plus 4 on the outside, that's shifting our graph either up or down when you have something added on the or subtracted on the outside of the function. When it's being added, it's actually shifting it up. Okay, so this plus 4 is going to take our basic graph right here, this y equals x squared, and it's going to move it up 4 units. Okay, this minus 2, when you have a plus or a minus on the inside of the function, and when I say the inside of the function, if my function is y equals x squared, then the inside of the function is the inside of what's being squared. The subtraction sign is actually going to move us to the right too, and a plus sign here would move us to the left too. So it's counter what you would think. You would think negative would move you to the left, it actually moves you to the right. Okay. All right, so what this means is I'm going to add 4, and you have to think about when you move up, you're actually adding 4 units to your y coordinate, right? So I'm going to add 4 to the y coordinates of my key points. This right here means that I'm going to add 2 to the x coordinates of my key points. And then all I have to do is take the points that I've shifted then and just plot them. And then I can draw out my graph. Okay, so if I add 2 to the x and add 4 to the y of these key points right here, then what I get is add 2 here and 4 there. My 0, 0 points becomes 2, 4. Okay, add 2 to the negative 1, I'm going to get 1, 5, and then 3, 5. Add 2, I'm going to get 0, and add 4, I'm going to get 8. And then add 2, and I'm going to get 4 and 8. Okay? All right, so that's actually what we can now just graph those points. And I guess it's going to be up here a little bit. So it's shifted us over 2 and up 4 for the vertex. And then if we graph these other points, 1, 5, 3, 5, we have 0, 8, and 4, 8, and then there's our parabola. Okay? Okay, so the one other thing to show you is what happens when you multiply by a negative on the outside, or the inside actually. So let's just take this same basic function. Okay? When you multiply by a negative on the outside, you're actually going to have to multiply the y coordinates by a negative 1. Or a negative whatever that number is. You're multiplying the y coordinates by this. It's actually going to flip the graph. Okay, if there's a negative in front of the x, you'll have to deal with that also. I guess maybe I'll have to do another video on that actually. But let's just talk about this scenario right here. So it's basically this graph, except here's a really important key on these, is you have to do any multiplication first before you do any addition and subtraction of your key points. So if I'm going to multiply the y coordinates by a negative 1 of my key points right here, which are, these key points, I actually have to multiply those by a negative 1 first before I add the 2 and the 4. Okay, so that would look like if I take these and multiply the y coordinates, 0, 0, negative 1, negative 1, 1, negative 1, negative 2, negative 4, and 2, negative 4. Okay, notice that that's just going to flip it upside down. Now I'm going to add 2 to the x, and add 4 to the y to complete where this is being shifted. Okay, so it's basically going to flip it down. It's going to flip this basic graph down, and then I'm going to move 2 to the right and 4 up. Okay, so this is going to become 2, 4. Add 2, and I'm going to get 1, and then 3. Add 2, I get 3, 3. And add 2, get 0, 0. And then add 2 and get 4 and 0. Okay, so let's take those points and graph them. So it's going to look like, okay, so we're graphing 2, 4, 1, 3, 3, 3, 0, 0, and 4, 0. Should be flipped upside down. Okay, so we've got the 2, 4. We've got 1, 3, and 3, 3. And then 0, 0, and then 4, 0. So that's the graph that we had before, but now it's flipped down. Okay, so that's kind of the gist of how I use key points. And you need to identify key points for all of the other functions that are possible. The way to do that is to take the basic function, do an XY chart, and see what those basic points are. So, if you wanted to continue along those lines, for instance, y equals x cubed, basic excuse me. If you just took a basic XY chart, choose -1, 0, and 1, you're going to find -1, 0, and 1. Those are your key points. Okay. All right.